A project demonstration of the prototype Blinkia View for embedded systems development. The proposed product is a novel way of connecting busy loved ones from a distance. Part of the system is a physical device and the other part is a mobile application. It communicates over an internet connection and only the two people who have access to the system can use it. So it's more personal when you know that when you receive a notification from the system, it is only from your loved one. How it works. To demonstrate how the system works, I've created a short video, which I will now play. So when the on button is pressed on the app, the LED turns on the device. When it's turned off on the app, the LED turns off on the device. When the button is pressed on the device, the physical button, the LED will turn off and the mobile device will receive a pre-programmed message notification. It also switches the mobile button to the off setting. The physical button can also be pressed again and it will turn the LED back on, the physical button to on, and also send the notification again. The notification that is sent by the Blink app the Blink app doesn't have to be open to receive this notification. When the notification is sent, it will pop up on the home screen like a normal text message notification. So the system communicates using TCP/IP communication protocols through the Blink application. It's an event-based real-time system, which means when an event is triggered, such as the user pressing the button, the LED switches and the notification is sent instantaneously. This is also a distributed system, which means the components are located in different locations and use different networks, but is still able to communicate with the two parts and pass the signals and messages between them. The device design. The prototype has been wired up using unsoldered connections on a breadboard. The LED has been connected to the particle photon through pin D1 and grounded through a resistor. The physical button has been connected to pin D3 and is also connected to the ground. The mobile application used is Blink, an Internet of Things platform as a service application. This app controls half of the device. It is free to use for basic projects and just requires an account to be made. To use the app, create a new project and add the particle photon as the device to be used. The project will then generate a unique authentication code that can be referenced in the particle photon code to be flashed to the device. Widgets such as buttons can be added and pre-programmed. The project is fairly fault tolerant. There is uninterrupted execution through the use of if-else statements in the code, and it is able to be connected to a portable power source and particle sim if you don't want to rely on wall power and home Wi-Fi. The project operates in real time based on the event trigger of the users operating the button. It doesn't require memory allocation, and so it should be efficient. The code has also been optimized through the use of variables, functions, libraries, and sequence. There is little maintenance required to keep this project running. The code can be updated remotely over an internet connection if required, and the hardware is low maintenance and should be long-lasting if it's secured away to prevent breakage. The project is reliable and can be made portable for both users. It is low cost, robust, and is very user-friendly with only one button required per user. To address some questions that have been raised. First, does it work properly? Yes, the prototype works as expected, with both buttons acting as a switch for the LED. Why didn't I use a light sensor to adjust the LED brightness as proposed in my pitch? Well, I determined that the LED didn't really require adjusting as it's not overly bright in the first place, and since the intent is to catch the eye of the user in the home, I wouldn't want to dull the LED too much. The next question is, why didn't I use an LED display as proposed in my pitch? Unfortunately, either my wiring was wrong or perhaps my code, but I was unable to get this working. So instead, if I were to go further with this project, that would be an improvement that I would make. The last question is, why use the particle and not any other system? Unlike other devices, the particle photon is purpose-built to use Wi-Fi without any additional add-ins. My final vision for the product would be to encase it in a shadow box so it can be displayed and the hardware can be secured. I would like to perhaps expand from one LED into a graphic display, and I would like to use the LED display to send a message from the mobile to the device. Finally, I would like to modify the code to make the LED actually blink.